Hello friends, in this video I am going to talk to you about estimating the amount of sodium chloride and potassium chloride in a given sample by Argentometric titration. Okay, so what is the question? The question is, we have got a sample with 75% weight by weight of NaCl and 25% weight by weight of KCl. Okay, the sample was dissolved in distilled water and titrated with 0.1 molar AgNO3, and the liberated AgCl PPT was washed with distilled water and dried in an oven and found to contain 2.8664 grams of silver chloride. Okay, so from this we have to find the weight of NaCl and KCl in the sample in grams. Okay, so how are we going to approach the problem? So we have been told that the sample contains 75% weight by weight of NaCl and 25% weight by weight KCl. So if M1 and M2 are the masses of NaCl and KCl respectively, okay, in grams, then we know that M1 by M2 will be 75 by 25, okay, will be is equal to 3. So M1 is 3 times more than M2, which means the weight of sodium chloride is thrice as the weight of potassium chloride in the sample. Okay, so this we will use later. Okay, this fact we'll use later, and now we will decipher the Argentometry. Okay, so when the sample is dissolved in distilled water and reacted with 0.1 molar AgNO3, both the NaCl and KCl react with AgNO3, right, in a 1:1 molar ratio. Okay, to give AgCl also in a 1:1 molar ratio. As you can see, NaCl will react with AgNO3 to give NaNO3 plus AgCl. Once again, the NaCl, AgNO3 and AgCl 1:1 molar ratio. So also KCl in the same way. Okay, KCl, AgNO3, AgCl into 1:1 molar ratio. Okay, so now we are also told that the combined weight of AgCl PPT from both the NaCl and KCl is 2.8664 grams. So now this corresponds to 0.02 moles of silver chloride, because if we take the molar mass of silver chloride, which is 143.32 grams per mole, we find that 2.88664 grams corresponds to 0.02 moles. Okay, all right. So now how are you going to calculate this? So let X be the number of moles of NaCl present in the sample and Y be the moles of KCl present in the sample. So now X moles of NaCl will react with X moles of AgNO3 to give you X moles of AgCl, right? Because the molar ratio is 1:1:1. Similarly, Y moles of KCl will react with Y moles of AgNO3 to give you Y moles of AgCl. So which means there's a total of X plus Y moles of AgCl in the system, which we have calculated to be as 0.02 moles, right? Earlier we calculated that. So X plus Y is equal to 0.02. Okay, now we know that X is the number of moles of NaCl is also equal to the mass of NaCl, which is M1 by its molar mass, right? Capital M1. So we know that the molar mass is 58.44 grams per mole. Similarly, Y, the mole of moles of KCl is equal to the mass of KCl, which is M2 by its molar mass capital M2, which is 74.55 grams per mole, the molar mass. So Y is the M2 by capital M2. So substituting for X and Y, we get this equation: M1 by the molar mass of NaCl plus M2 by the molar mass of KCl, you get 0.02 moles. We also know that M1 is equal to 3M2, right? So we bring that here, we substitute for M1 with 3M2, and we get this equation, right, of 3M2 by M1 plus M2 by M2 is equal to 0.02. We rearrange that equation, okay, do the jugglery and everything, and we get M2 as 0.02 into molar mass of NaCl into molar mass of KCl, the entire thing divided by 3M2 plus M1. Okay, all right. So we plug in the values. Okay, M1 we know is 58.44 grams per mole. M2 we know is 74.55 grams per mole. All right, and this we plug in the values and we get M2, the mass of KCl, as 0.3089 grams. And since NaCl is 3 times that value, we multiply 0.3089 with 3 and we get 0.9267 grams. So the weight of NaCl in the sample is 0.9267 grams. The weight of KCl in the sample is 0.3089 grams. Thank you.